My name is Donny Davis. I work for Red Hat. I'm the lead cyber architect for the DoD.
Isn't that technically IBM now?
Is it not technically IBM? It's technically Red Hat. The deal's not going to close for like another year, and even when IBM does eventually pay for Red Hat, we still operate as an independent unit. So Red Hat's not really going to change because we have collaborative partners in HP and Dell and cooperation everywhere. And Red Hat's got their hands in everything. That's why IBM sees $34 billion in value. So Red Hat's not really going to change as far as what we do as a company or how we do it. We're really there to provide the hybrid cloud capability for IBM because right now they have no on-premise. Nothing on-premise that they can do, and it's cheaper to buy than it is to build.
So it sounds like IBM was interested in OpenStack as a
They're
major
interested in OpenStack, and they're interested in Kubernetes, but I mean, they could have got that stuff from upstream. So if they wanted to acquire the intellectual property, they could have just downloaded it off the internet. It's free. There's no software at Red Hat. I mean, the largest news organization in the world produces no news, and the largest software company in the world apparently produces no paid software. So.
Yeah, this gives IBM a real operating system, if you would. Like,
I don't have one.
well, right, they never had a real operating system before. Now, like Microsoft had, was never Windows, so now they have a real first time real operating system and a cloud, right?
Right. They already had a public-facing cloud, and IBM is looking for that hybrid strategy, and you were kind of talking about that a little bit, and that is the future of where people are going. Essentially, public cloud is commoditizing compute, networking, storage. That's what's happening. Is it's making it like electricity, where you just turn the light switch on. You don't care how it happens. You don't care that they use diesel generators or nuclear generators. It doesn't matter. You just want your light to turn on. And that's kind of what the public cloud is doing with not just virtual machines. Virtual machines were just really the start of that capability of what a cloud can offer. They offer software-defined compute, network, storage in 3 different flavors of storage. They offer APIs for everything as a service. If you were to think of a computer and break it down into components, individual components, Amazon and OpenStack both provide APIs for each one of those individual functions. It's more than just a virtual machine. Virtual machine technology is about 20 years old at this point. It's pretty mature. I want to say the first hypervisor came about in the early 2000s. It didn't work very well. It was a Zen hypervisor. And it provided basic functionality to fabricate a BIOS. That's what virtualization is I fabricate BIOSes from nothing. And the next transition into that is providing well-defined APIs for each one of those individual functions. So as Amazon or IBM Cloud or Azure or Google are to public cloud, OpenStack is to private cloud. If you wanted to build an infrastructure that has those well-defined APIs, I'm going to skip through a whole bunch of these slides. This is the same presentation. I think you were here for the last one. You're the only one I remember from the last time I gave the OpenStack presentation.
Is that a good thing or a bad thing?
I don't know if it's good or bad. So we're not going to cover this whole slide deck because there's a lot of stuff in here. We went a little further in depth in talking, and today we're going to go. We're going to stay at the top, and then we're going to do some touching. So what is the cloud? And really, it's kind of what I just said. It's software-defined compute, network, storage, anything that is a function of a computer. It is defined in software as opposed to being defined in hardware. I can make an API call and get CPU cycles. I can make an API call and get file storage or block storage or object storage. Instead of having to go out and buy a physical resource, I can just throw it in the public cloud. And a lot of organizations, if you look at the government organizations, if you look at financial services industry, if you look at oil and gas, they're not going to take all their data and put it in Amazon's hands. And there's a very good reason for that. If your business is betting on your data or on your capacity to use CPU cycles, then it's a poor bet to make to put all your eggs into one basket. And you see examples of this happen with the previous industry change where electricity used to be generated regionally and everything got kind of collapsed down into large electricity manufacturing systems, much like the public cloud did. And the example is when somebody goes out and buys a generator because they don't count on the electrical company to provide them with power. It's critical to them. They have to have it. So they have a hybrid capability where they can produce their own power if they need to. For 9 times out of 10, they're using the public service provider's power. But in the event that something critical was to happen, they'll just turn on their own generators and produce their own power. So that's kind of what this hybrid cloud idea really is. It's more designed around that compute, network, and storage have become commodities, and how to build a generator that is equivocable to what the power company provides or what the public cloud provides. How do you get that on-premise? And that's kind of what OpenStack does. Cloud service models. So, infrastructure as a service. When I say infrastructure as a service, what do you guys think of? What do you think of when I say the word infrastructure? That's not a rhetorical question. I'm hoping somebody will answer.
Setting up databases using I would define it as literally whatever the cloud provides, standing up those things, but not the data.
So infrastructure. So infrastructure is that router and switch over there. Right. Infrastructure is quite literally the actual pieces of metal that you connect together to make it do something. A database or a web server, that's an app. That's not infrastructure.
I mean, but if you look, I mean, it's just that when you look at that standard IAAS SaaS model, they show the operating system right. They show the operating system layer as an IAAS, right? If you look at like AWS, it's typically when you're looking at intro to cloud program. I mean, so I'm just saying that. Why are you excluding operating system as an infrastructure? Just considering it bare metal.
Because the operating system is something you consume, not something they provide. That's why. When you make an API request, you don't make an API request for an operating system. You make an API request for a compute service. You make an API request for a processor, or a switch, or a router, or a block device. It's much further below the operating system level. Infrastructure as a service is taking what are physical components and putting an API in front of them. That's what it is.
Yeah, I think that's kind of relevant from the standpoint if you have regions where you have to have timely access to customers, you're not going to put your infrastructure in the bells of your customers and employee, right? So that's where IAAS kind of separates itself from the OS. So think of infrastructure as regional hardware that you can use and utilize as appropriate.
Right.
So if I make an AWS call to stand up an RDS database, would that not create infrastructure?
So that's not infrastructure. That falls into a separate category, and that's not part of something that would be infrastructure. So they put down the operating system, and they make API calls down to the EC2 service, to their compute service. They make them to their network service. They make them to their storage service, and they just kind of abstract that away from you. That's really how that works on the back end. When you make a database API call, that database function that they have on their side turns around and talks to all the components that it needs to. So it makes setting the database up very easy for you, and you can make API calls to be able to set that database up or set that web server up. And that's not the only service. They also offer functions as a service, containers as a service. They offer a whole bunch of different services, as does OpenStack. But it's really not infrastructure. Just because it's got an API doesn't make it infrastructure. Infrastructure are CPUs, RAM, switch ports, router ports. That's real infrastructure. That's what things are built on top of. So OpenStack provides a private implementation of infrastructure as a service. That's all it is. Everything else you build on top. It does offer a database as a service, which is essentially what it does the same thing that Amazon's database service does. So you can layer platform as a service or software as a service on top of infrastructure as a service, and that's typically how people do things like that. Most people think of infrastructure as a cloud as being these hyperscalers. So you look at hyperscalers like Amazon or Google or Azure. In most people's mind, that's the only place a cloud fits. But if you look into the telco industry, they see that much differently. They see infrastructure as a service. So we work with Verizon and AT&T at Red Hat. Collaboratively in the OpenNFE community, I think you guys have made some pretty significant contributions to OpenNFE. They are taking private cloud and seeing it more for what it really is, and it's infrastructure as a service. They want to be able to automatically orchestrate network events, and I'm sure you could talk at depth on specifically how that works, but the broad scope of it is the cloud doesn't specifically have to be big. It doesn't have to be Amazon sized to get the usefulness out of it, where I can create whatever I want. I can fabricate things out of thin air. I can fabricate switches, routers. I can fabricate network infrastructure, storage infrastructure, or compute infrastructure from nothing. That's kind of what OpenStack does. So how can you get access to OpenStack? What methods do you have to get access to software right now? OpenStack is a free and open source project. So all the code is hosted on the OpenStack Foundation. You look like you're going to say something. Oh, okay.
No, thank you.
So OpenStack's free. You can get this. You can get access to this technology for free. Can you put it in production for free? That's to be determined. But if you have the kinetic effort, I mean, if you have an Amazon-sized organization, you probably can. And you don't need to pay for it. But it's really about what the OpenStack Foundation is about and what they do. And they provide a construct for developers to contribute this code, to take bits of infrastructure and put an API in front of them to make it do something useful.
How did the RDO part come into being?
They ask, everybody always asks that. It's the RDO project. I would say Red Hat's distribution of OpenStack, but it kind of makes sense. The RDO project is the upstream for Red Hat's OpenStack product. And there's a lot of advantages to using a community and not going directly to the OpenStack Foundation. So when you pull code out of pip or get it from GitHub, who QA'd and QE'd it? Well, you just did. If you use a community project, you don't have to worry about somebody QAing something or making sure a package installs correctly. They kind of take care of those things for you. That's the purpose in using a community. It's much like what we have here, where we kind of help each other out. Well, that's what communities do in the free and open source software world, is they kind of make things easy on everybody else. Scratch each other's back, everybody contributes, everybody gets something back out of it. And RDO is the distribution. So RDO is in production in a ton of different places. So if you look at CERN's data center, I'm not sure if you guys have ever heard of CERN, but they take particles and smash them into each other at scale, capture terabytes of data a second, and they use OpenStack to do that. They used to pay lots and lots of money for really expensive SANs and really expensive virtualization, and they commoditized all that stuff, and they were able to save themselves a ton of money doing so. So they use exclusively RDO. And I know everybody's kind of moving forward with that stuff, but it's where you can get access to OpenStack for free. So what is OpenStack? And you're going to see all these crazy project names. They don't mean anything. The names of the projects they don't really mean anything. What you need to see them as is what their service is. So if you need a compute function, the name of the project is called Nova, but really it's important that it's the compute function or the image store or the network. Don't get too confused about the project names. Why do they do that? I don't know. That's just what they did. Just kind of keep all these separate independent projects. So each one of these independent services has its own PTLs. They have their own project leaders, so they can take their project in whichever direction they want. They're all completely segmented, which has really allowed the OpenStack community to grow in scale as far as like developing code and getting it into a production-ready state. These guys here don't really depend on these guys here. They're kind of independent projects, so they can move at the pace and distance they want to. And it's allowed the model that they've created for software development at scale is unprecedented. There's not a bigger project out there than the OpenStack project as far as contributions from a number of vendors. And it's really more about how many people are contributing versus lines of code that get written. There are thousands and thousands of contributions that come in from everywhere to fix small things, maybe fix big things. But OpenStack, as far as the number of people that were contributing to that project, is immense. It is incredible, and to see that done at scale, they solved a whole bunch of problems. They ended up starting to use OpenStack to build OpenStack and make OpenStack, and they created a whole bunch of software projects to build out pipelines, to create all these projects, and let them flow freely. So when a developer
Is it
submits
easy to
code,
get involved with like being a little tiny contributor to like an OpenStack?
I'm a tiny contributor to OpenStack. I have 2 lines of code in OpenStack right now. I have 2 lines.
So how does that work? Like, I mean, like you see a problem, and then like, how does your fix get into the community to get accepted, even though it's 2 lines?
So this is a really interesting topic, because it's directly related to how OpenStack is made. So they use a Git review system, which is a battery of automated tests. So let's say you see a patch that you can write, like I can fix this. It might be documentation. It might be a fix in the API itself. It might be an orchestration template. It could be anything that you're providing to the community. And you sign up on Launchpad. That's what they use as their back end. You go into the Git service. You push the code into the Git service, and that kicks off a build chain of events that happen. So OpenStack has developed a continuous integration pipeline that automates everything up to the point where a human needs to check and make sure that it all worked, and then merge that code. So they use the Git review methodology of doing that, and I believe they use Software Factory to run, and Zool to run it through the actual pipeline. So when you submit a piece of code, that actually kicks off a chain of events where they take that code, they build it against what's already been submitted, what's in the queue right now, what the current master looks like. And they've got a litany of scenarios, so I think there's like 12 scenarios that they're going to take your piece of code and they're going to run your code through that scenario, and that turns around and puts votes into a voting system. And the voting system allows your code to move through the process.
Wow.
It's pretty
Automated
crazy.
but complicated.
It's automated, but the only people that you know, all that stuff is just like the public cloud. Like, you don't need to know how complex Azure is. Really, all you care about is just submitting the code. Everything else is taken care of for you. You don't have to worry about any of that stuff. It's all a fully automated process up to the point where it's going to get merged into the master branch, and then a human being says, yep, passed all these checks, click the button, go, next. So that person that's reviewing that code can focus on other things that are more important. Yeah, if you guys want to check out software, if you want to see how they build OpenStack, check out Software Factory Project.io, I believe. And Software Factory essentially lets you build a continuous integration pipeline, and I'm not going to say that that's at least as complex as OpenStack, if not more complex. Writing automated tests is very challenging. Getting a pipeline stood up that you can actually do something with is very, very, very challenging. But it uses simple technology like Git, Ansible. Zool as a service is it's actually an OpenStack foundation project to solve OpenStack's own problems. So, and it's all, of course, all free and open source. So, most people, when they're used to interacting with infrastructure, they used to log it into the GUI to do things. They go into their little web console, they go into their client-side app, and they point and click their way around. And that is not what clouds are made for. You're not supposed to do that. You're clouding wrong. If that is your process, then your process is what physically broken. You're supposed to automate things. The whole purpose in the cloud is to start using tools that take care of tasks for you, so you can focus on what's really, truly important to you. Because at the end of the day, I don't need to make individual API calls to the compute service, the storage service, and the network service. I just care about my instance. I just care about my thing I'm trying to get a hold of. And they include this dashboard. It's called Horizon, and we'll look at Horizon. But you really shouldn't use it. So if you're going to check OpenStack out and you're looking for the web GUI to log into, to point and click your way to success, stop. You're not doing it use the dashboard to like review that something happened properly, so you can get some confidence, build some confidence in the API calls you're making, but don't use it to like do things. We're going to use it here because you guys don't. I'm assuming that nobody really knows how to make OpenStack API calls, and you don't have the client-side libraries installed, and there's a whole litany of reasons why we're going to use the dashboard, but it is not meant to be used. The APIs are. And each one of these projects you see, this is an individual set of API calls, or APIs. So
you don't need to install Keystone necessarily?
you have to install Keystone.
Okay.
So
That
Keystone,
we found out, yeah.
Keystone, so you can, there's ways to turn the Keystone requirements off. You can go and change the pipeline in the Python library. It looks at an INI file that tells it like, hey,
Okay.
these are all the things you need. These are all the Python modules you need to load.
Okay.
Just tell it not to load the one that looks for authentication. You can turn it off in most of the services, not all of the services. But like if you want to just run Neutron independently, there's about 1 billion ways to do that without having to do Keystone. But Keystone is essentially, it is called Keystone literally because it is the Keystone. Everything talks to the authentication service, so each individual API will say, hey, is this user allowed to touch this API? If they are, you know, what role do they play? What group are they in? It's kind of like the federated identity management service. By default, it ships with the MySQL database backend, but that was never designed to be in production. You're supposed to put like an LDAP backend behind it, Active Directory, something that really does that for like a project. So this is the Horizon dashboard, which you guys will see. Nova is the compute service. So the compute service is what takes care of making, when you send an API request to Nova, it takes care of spinning up your virtual instance. So Nova, and all of these APIs are just like they sound. They're just APIs. They rely on a back-end service to actually do real work. So when I make an API request into the compute service, it's going to talk to whatever hypervisor I've configured on the back end to work with it. So by default, I believe there's KVM, Hyper-V, VMware, Zen. Can't think of any. I think they support all hypervisors at this point. So Nova's just the API. It doesn't actually do anything. The hypervisor that it talks to does something, but it provides you with a common set of APIs. So if I had VMware infrastructure and I had Hyper-V infrastructure and I had a KVM infrastructure, I could make the same API request to every single one of those, and I wouldn't have to refactor my application. So when you start thinking about infrastructure as a service, remember that time I said humans don't point and click their way to success? So you start coding your application against this API, and I can swap out any of the back-end technology that I want to without refactoring my app. If that makes sense. Or my automation, if I'm using automation. So if I'm using like something like Ansible or Puppet or Chef to make OpenStack API calls for me, I wouldn't have to refactor my automation to change out my back-end technology.
Does Nova then do the same API, like, you know, the EXI host makes calls to the VMware infrastructure, right? So does Nova make calls, for example, when it's doing VMware, the same API type of call?
It does, yeah. It's going to call vCenter.
Though by VMware, and you wouldn't be able to make the same kind of API call.
Well, you have to have vCenter to use. You have to have vCenter. You can't just call ESXi directly. You essentially call the vCenter API, and then it takes care of everything for you. I mean, the only thing I have to say about VMware is hypervisors have been commoditized, like why pay? Doesn't make any sense. It doesn't make any sense. Why pay for something that's free? And that's how all of these services work. So if we look at the Keystone service is just a standardized API for whatever the back-end technology is. So if I'm going to insert a 389 directory LDAP database behind this to manage and maintain my actual users, and I want to swap that out for Active Directory, Keystone will allow me to do that because my application still makes the same API call. it still talks to Keystone the same way, even though the back-end technology could be entirely different. In most of these projects, you can set up multiple backends at the same time, so you could have more than one. If I was trying to make a transition from one technology to the next, you could very easily do that. Glance is an image store. So in OpenStack, you don't pop in an ISO and install an operating system because that's not very automated and that's not very cloudy. The assumption is that you will use a pre-provisioned image, and the image is already refactored or built for you by the vendor you get it from, by the open source project you get it from. Somebody has already produced an OpenStack image that is ready for use. And an image is nothing more really than a file system. It's just the file system with the stuff pre-installed. In the OpenStack documentation, they show you how to bake your own Linux images and Windows images. If you want to bake your own images, you absolutely can do that. I would steer you away from doing that because the communities that are out there do an extremely good job. They already have automated processes in place to bake these images. If you don't trust them and you want to build them yourself, you can absolutely do that as well. And they come in a little
did
different.
Windows images on it. You have to go out to Microsoft and buy like.
I'll show you.
What?
I'm going to show you.
Oh, you will?
Oh yeah.
Oh.
Oh yeah. Neutron. This is probably the most complex thing in OpenStack because network stuff has kind of been a black box to everybody except for network professionals for the last forever. Nobody knows how network stuff actually works. Neutron is essentially a front-end API to make calls back to routers and switches. So Neutron will allow me to fabricate network infrastructure. So when I create a network inside of OpenStack, a network is a switch, a real switch, and it will actually switch packets. When I create a router inside of OpenStack, it's a router. It will route packets. And Neutron provides a front-end API for a litany of vendors out there, some free, some paid. So if you want to use, say, Juniper or MitoNet or standard Open vSwitch, Neutron will provide you with a standardized API to make those infrastructure calls. Block storage, another.
Can I ask you a question? So are you saying when you create a router inside of the Neutron networking, are you saying that you, instead of just OpenStack router, that could be a Juniper router?
You could.
Really?
Absolutely could. Yeah, it depends on the technology that you're deploying and the way you're doing it. So in combination with services like Tacker, you can orchestrate Cisco CSR 1000s, you can do all kinds of things.
Yeah, I mean, I was thinking of, I mean, there's one, I knew you could put them on a VM and they're the router, but I guess what I was getting at was that instantiated router that you create in part of Neutron. And come out.
So if you, I mean, it depends on the network backend that you're using. So if you're using a standard OpenStack, the standard defaults that ship with OpenStack, it uses Open vSwitch and the Linux kernel to do those functions. Because the Linux kernel will route packets for you. It absolutely will route packets, in most cases wireline speed. And Open vSwitch is able to create virtual switches. So when I create a router inside of OpenStack, it will route traffic. It doesn't have any routing protocols on it because you didn't tell it that.
Oh, right.
But if you use a backend like MitoNet or Big Switch, those things do have routing protocols baked into them. So you can make an API request for a router, and when it's a router, you might want to tell it what kind of router it's going to be. But it will translate that stuff for you. So the backend technology will create a router. Not a hardware router, obviously, but software defined. Everything in OpenStack is software defined. Did that answer your question?
Well, yeah. Is MitoSwitch and Big? I know what Big Switch is, a big software defined vendor, but
MitoNet's the same thing.
I don't know about MitoNet, but anyway.
Yeah, Mitokura is a Japanese company that does the same thing, competitive with Big Switch. Juniper has Open Contrail. Red Hat has Open vSwitch. I think who else is out? Plum Grid. There's a huge swath of SDN vendors, and it's really around when you look at the term for OpenStack SDN. it's different from network function virtualization. Network function virtualization works a bit different, and we can talk about that when I get to this stuff too, if you're interested in network function virtualization, because it does work a little bit differently than software-defined networking. Storage is another black box to most people. You buy, you get an NFS server, you get a SAN, and you just let the SAN guy take care of it. Like, here, storage guy, do this thing. And CINDER allows you to plug your SAN into a standardized API. You can plug NFS into it, you can plug Ceph into it, you can plug a litany of different storage technologies that would allow you to connect block storage devices. That's what it does, is block storage. Swift is an object store. If you guys are familiar with Amazon S3, if you use S3 right now, OpenStack has that too. They call it Swift, and there are a number of backends that you can use for this as well. So there's metering, metrics, orchestration. So if you're familiar with, I believe it's Cloud Formations and CloudWatch. That's what Heat does. OpenStack Heat will allow you to put in a template, and it will just take care of a bunch of things for you. So, for instance, if you had an application that would auto-scale very well. So when I say auto-scale, I mean just create instances of itself to scale out instead of creating a bigger image or bigger VM. The scale-out methodology is firing up a load balancer and putting a whole bunch of VMs behind a load balancer. So let's say I had a web application like WordPress or something like that, and I had a couple of million users, but they only logged on at 3 p.m. Heat would take care of spinning up all the instances to automatically scale that WordPress application. And there's actually an example of that in the OpenStack docs of how to do auto scaling. So it gathers the metrics for the instance. And the old way of doing things is that if an app needed more resources, you just added more CPUs and you added more RAM. The new way of doing things is just adding another instance. And when the load is gone, you tear the instances down. That's kind of that's why clouds are beneficial. And that's really kind of geared towards the hyperscalers. So if you look at a company like Netflix or Hulu, I don't think Netflix is in Amazon anymore. I think they're back in their own private data center. But I'm pretty sure Hulu is still in Amazon. So at 5 o'clock, Hulu is going to start scaling, 5 o'clock in the evening, given a region, going to start scaling their instances up to support their streaming service. Because there's no sense in paying for those instances while they're not really being used. And that is the purpose in having a powerful orchestration engine to do that stuff. And you can do that privately with OpenStack. You were asking about database as a service. Trove, they do have that. It's called Trove in OpenStack. And you can make an API request. It just spins up a database for you. And I think there's MySQL, Postgres, and there's one more in there. And there's a whole bunch of others. This is not a comprehensive list of OpenStack services. It really is just kind of scratching the surface of what you need it to do. If you have a pointed use case. Like, I use OpenStack at my house as my physical infrastructure. So my edge router is OpenStack. I just use the network functions that are in there, so I don't have to configure switches and routers anymore. Just do that and stuff in software, because it works. If you want to know more, you can go to openstack.org, check out the project navigator. Installers. Now this is a bit of a complicated topic because everybody has their own OpenStack installer out there, and you're going to find about 60,000 different ways to get OpenStack installed. And I will tell you guys that I've tried them all. The simplest one is this fellow right here, PackStack. It's an RDO project, but it just works. It'll create, and for most people's use case, when they want to get started with OpenStack, they don't have 20 servers to put it on. They're going to put it on their laptop. PackStack will do that for you.
How different is it from DevStack?
Significantly different. DevStack is what the actual OpenStack developers use, or it's designed for the OpenStack developers to use to get OpenStack spun up to develop the APIs. So some of the stuff you might get in there will be broken. It's not really designed to be used. It's designed for developers.
I mean, I installed DevStack kind of very easy, but
Oh, yeah,
I was
it's
afraid
easy.
of it. I didn't know how different it was from the real OpenStack, so it's like thinking it's
They're the same thing.
critical.
Like OpenStack is OpenStack is OpenStack. If you're installing the OpenStack libraries and APIs, it's going to do the exact same thing. Now, how DevStack configures things is entirely of its own making, and is not even close to being set up to something I personally would trust to run any sort of workload on. The real test is to reboot the box. Once you spin it up at DevStack, if you can't reboot that box and have it all turned back on, then it's kind of pointless.
I mean, I've created a bunch of DevStack instances on EC2 instances, and that worked out okay.
Yeah.
And then I needed the apps.
And if you guys want to try out the bare metal version of that, you can go to the Packet Cloud. If you guys are familiar with Packet.net, they offer a bare metal cloud. It's like $32 a month for a bare metal instance. You could put OpenStack on the cloud and run real VMs and not get the nested virtualization latencies or anything like that. Or have to use QEMU because QEMU is not great. But if you guys wanted to test OpenStack out, Packstack. That's the way to go. Promise you, there's not an easier way out there. It's like 3 commands, and I'll pull those up. And then if you want a production setup, so if you do have 20 servers and you do want to build a production grade cloud, O is the community for actually getting OpenStack installed in a production fashion. I'm not going to say O is easy. I mean, if building a cloud was easy, everybody would already kind of have one. So it's not easy. It's designed to be flexible. It's not designed to be easy. So the burden of learning is on you, and you'll very quickly figure out what not to do. So this is kind of what OpenStack looks like, graphically. If you were to look at the inside of Amazon's cloud, it probably looks pretty similar. These are all the connections it makes, and all the things that it does, and all the things that it talks to. It's complex. It's not designed to be easy. It's designed to be flexible. Can't have both, unfortunately. I think we already covered in detail. So how is OpenStack different from Amazon? I can't put Amazon on my laptop. I can't bring that in-house. I cannot take a full-blown Amazon cloud instance and provide every single API that Amazon provides and run that at my house or in my data center in my business or in a government data center somewhere. You can't unless you have $1 billion to pay Amazon to build one for you, because if you do have enough money, they absolutely will come build you a cloud. I believe the intelligence community has one right now.
C2S.
They might, C2S. They have. I think they even have two. So there's SC2S, which is entirely independent.
And China has their own.
Yeah, I'm sure if you have enough money, Amazon will come build you whatever you want to, but you're going to pay for that. Amazon was never designed to be cheap. It was designed to be easy. So how does OpenStack compare against Amazon? It provides most of the services that Amazon does. If not, there's some differences in there. It also has compatible API calls that you can make. So OpenStack also includes a mimic of the EC2 API. So if your application is already written to Amazon, it is very likely that you could port that into a private data center on OpenStack because it offers all the compatible API calls that your app's going to make.
When do you think that's what IBM and Red Hat are going to do then, is have a cloud infrastructure? It'll be like an OpenStack service infrastructure?
Well, IBM already has their own public cloud, so they bought software a long time ago. And IBM has a public cloud, and that's why I say our vision of the future is this hybrid version where people have an on-premise generator and they still get their power from the power company, where they'll go to the public cloud for a lot of their needs, but they will also maintain some data on-premise. So say you're a credit card company like Visa, do you think that Visa should trust Amazon with your information? I don't know how people would like that. Might drive business away, might affect business for them. So we see the future as companies like that would maintain their own data and maintain their own infrastructure, but they still want the capability. They still want the usability of the cloud, but just maybe not all into it.
I mean, what I'm saying is you're then competing against the hybrid cloud like with VMware, then you can float RDO between a private instance and a hybrid, and it in the IBM cloud or make it a private instance, right? Like the
Right.
VMware cloud.
Well, VMware is not a cloud. I mean,
The hybrid VMware cloud.
there's no hybrid VMware cloud. That's a myth. VMware is virtualization, and I'll just be quite frank with the way that VMware is. It is traditional virtualization that is designed around a human driving it. That's the whole system, the whole ecosystem was designed around, because at the time, the whole REST API-driven infrastructure, it wasn't a thing. It just wasn't a thing. So VMware was designed around having a human being that sits behind his computer and he drives it. He's
That
the
was
one.
the norm when they started.
It was,
Yeah.
and it was, and they did very well with that model during their time. But their time is over. It's been over. Like, people aren't doing that anymore. Learning VMware today is useless, because that's not the way industry is driving. It takes years to learn how this technology works. I've been working with OpenStack for almost since its release, maybe 6, 7 years. I've been involved in the OpenStack project, and the future's headed that
Can
direction.
I got a challenge on that.
Sure, go ahead.
Because, so I interviewed with Dell over the summer,
Mm-hmm.
and they had just told me that like they had just gotten all their Dell guys VCP data center
Mm-hmm.
6.5 certified.
Yeah.
And one of the things the
So
guy
they certify
told,
their people in 20-year-old technology.
Well,
Congratulations, Bill.
one of the things the guy told me was he's like, I'd really like for you to get the
Mhm.
VCP 6.5.
Mm-hmm.
But I've been looking at it, it's like $4,000. Like VMware, you have to pay them to take their class before
Mhm.
you can sit for their test, which seems like a bit of a racket. But like that's Dell, they're huge,
Mm-hmm.
and they're still big on VMware.
Means nothing to the rest of the world. That's not where industry. I mean, I talk to industry people. I go out and do this stuff for a living. That's my job, and that's not where industry is going. People
Well-
are leaving their OpenStack behind. If you look at an organization, you can't say a whole lot of stuff because it's streaming. As soon as the camera's turned off, I can finish that conversation. But that's not where industry's going. It's where they've been. So just because somebody has VMware in their data center right now, doesn't mean that's where they're going to be in 5 years. They probably are not going to be there. There's a very good likelihood that they will be in the public cloud, they'll be in Azure, they'll be in Amazon, and they may have a small subset of technology left on premise, very small.
But you also
That
have
doesn't require a guy to maintain it anymore. Like, they'll just contract that stuff out.
You also have to look at what Dell's business model is.
Yeah,
They're
but they paid
not
$17
selling
billion.
servers to Amazon. They're selling servers to Frederick County. They're
And
selling
SEC.
servers to people who still probably end up using VMware
Mhm.
because they're not in the cloud. They're
Yeah.
not even looking at OpenStack. They have people that are at the desk running VMware.
Mhm.
That's why. That's why.
Yeah, and
If Dell was selling servers to Amazon, it'd be a different story. But Amazon builds their own.
Yeah.
well, and I know Google doesn't build their own anymore. They get them from Dell. Yeah, you can buy the old Dell server that was made for Google on eBay. They're out there.
I'm completely full of crap.
No, you're not completely full of crap. They used to build their own custom hardware, but Dell must have cut them a good deal or something.
Probably,
And it might only be for their storage servers or something like that. But that's the important thing to learn here. The important concept to grasp is learning old technology doesn't get you down the road. And really, virtualization is dying on the vine right now as a technology. Like, people just don't really, that's not where they're going. Everybody's going to containers. You can look at the writing on the wall. Go look at the Kubernetes go look at Kubernetes as a project. And the number 1 contributor is Google, the number 2 contributor is Red Hat, and the number 3 contributor is Microsoft. So
Yeah, I
if
mean,
that tells you.
The foundation, the orchestrator we're doing is all container based.
Yeah.
There's OpenStack involved because you have to, but the ONAP itself is headed toward Kubernetes.
Yeah,
So
everybody is.
we actually use Rancher and
Mhm.
Kubernetes
Yeah.
and OpenStack platform.
Sure. And that's a Kubernetes distribution. Kubernetes is a better scheduler. So OpenStack's like OpenStack Nova it's a scheduler, right? It schedules things to happen based on infrastructure. Kubernetes is also a scheduler, and it's a very competitive scheduler. So, and there's a lot of hype around containers right now. I don't think OpenStack's going anywhere as a project because of its presence and its use case, because it's designed around being infrastructure as a service, not apps. It's not designed to run apps. It's designed to control infrastructure, so it's got very heavy use cases in the telco industry, in the government industry, and anybody who's running big networks. So when I say big network, I mean something that spans worldwide and has hundreds of thousands, if not millions of users. They still have a very genuine use case for OpenStack. But their future is containers. Like, this virtualization stuff is dead. It is dead. It's not dying, it's dead. Nobody's, people, if you go look at, right now the cybersecurity companies are all over it. They're the ones that are kind of on the bleeding edge as far as that's concerned, but they've already got their apps packaged in containers and with a push button template inside of Kubernetes. So you push a button, it just turns everything on for you. You don't have to think about anything. And that's the model. That's what people want. They want what's on their phone. They're like, why can't everything just be as simple as my phone? I open the app and it just works. Why can't infrastructure be that simple? Well, it can, and they're going to use containers to do it.
So, I mean, that's where OpenShift is.
Mm-hmm.
But then how do you see OpenShift and OpenStack kind of coming? Do you see that? Is that really going to come together and kind of merge into one?
I don't know if it'll merge into one. They still have different use cases. So their function and their purpose is different.
Well, I mean, if we had a container-based world, OpenShift would take the lead.
Probably, and it probably will. As far as developer contributions, it's going pretty fast. As far as like, where are open source developers developing their code? Container technology is where they're putting all their effort. And the reason that I say these, the proprietary companies aren't going to make it, like their products aren't going to survive, is because the open source development methodology is better. I mean, why did IBM pay twice as much money for half of a company like VMware's bought for $17 billion? So it should tell you something. When I believe it was EMC, wasn't Dell, because EMC bought VMware and then Dell bought EMC. So when EMC bought VMware, they paid $17 billion for them because all they wanted was their IP. They just wanted their sales. They wanted their revenue stream. Why pay $34 billion for a company that has less revenue and less people and no code? It's because open source won. That's why. Open source is the way that technology is developed. Even Microsoft says so. So it's not just us. Yeah.
Finally.
I know, right? The CEO, what's her name? Nadia? CEO of Microsoft.
You mean
Her. It's a female, yeah, the CEO. She was saying that Microsoft is going to be the largest open source company in the world by the end of the year. Even the Microsoft CEO is saying it. Like, it's got to say something.
Actually,
about where
our
the industry's
last
going.
month's presentation was Microsoft's use of open source.
I know,
And
right?
how
It's
much
crazy.
they are into it. We talked about Azure a lot and
Right.
everything else in there.
I mean, it's
And
just crazy.
PowerShell with Unix type commands and all that.
Yeah, I mean, that's where they're going. So that's that legacy technology. While it's there today and it's got a strong foothold today, it's not going to have a strong foothold tomorrow. It's not worth people's time and learning and investing. Of course, Dell's going to tell you that because they sell it.
Yeah, I didn't know the BMC bought VMware.
Yeah, VMware's was owned by EMC, and then Dell bought EMC. And I want to say they spun VMware back off and then like bought back into Dell or something like that. It's a whole, yeah.
I think the biggest reason that VMware is last as long as they have, you look at their certification process allows for engineers to support the product in the data center.
Mhm.
That's why they've been around as long as they have been.
Mm-hmm.
The biggest reason Red Hat problems back in the 90s was the lack of engineers.
Mm-hmm.
I couldn't walk down the street and grab a Red Hat engineer if I could find three Microsoft guys.
Mm-hmm.
So when it comes down to supporting your customer, if those people would do that, and that's why you saw that kind of paradigm shift over the last 15 years from
Mhm.
closed source to open source, because as the people are graduating out of college
15
and making
again?
those contributions,
Yeah.
you had more eyes on code, and I mean, and that's why you're seeing Microsoft shift towards open source too, is because it's when you have 10,000 people looking at code versus your 3,000 hired engineers,
Mm-hmm.
you're going to find things like this last June where Red Hat had the DHCP bug,
Right.
-R, where you could exploit a box,
The WPAD vulnerability, right?
Yeah, right. So you think about something like that. I mean, how long would it take for Microsoft to find that on their own without having closed source, right?
Right, forever. It'd take them, if it ever got found, I mean, somebody had to be looking for the exploit. I mean, I absolutely
Right.
agree with that statement.
I mean-
That's the why for why open source works as well as it does.
Yeah, because of the level of scrutiny it faces, not only defense measures but offense measures.
Yeah. And if you look at, you know, if you picture yourself as a developer, I'm somebody who writes code. I'm about to publish my work on the internet for the world to see, and that reputation kind of follows me. You can't get away from it. It's on the internet. So developers focus a little more time, energy, and effort on writing a little bit better quality code. I'm not going to say that that's true for everything, because I write some pretty crappy open source code. But
I mean, we spend a lot of time telling the DoD that open source is a good thing.
It is.
You know, it's checked and it's good, and you can use it, and we apply the proper cybersecurity techniques and scanning and tools and efforts to it. And it's as good as ever, and we found they're accepting it.
The people that I work most directly with in my role as the cyber architect at Red Hat, I find that everybody is quite open to open source technology, because the old way didn't work. If it did, then they wouldn't be trying something new.
It's too expensive.
Yeah, it is, and it is very expensive.
The old way's too expensive.
So it isn't, to answer your question, I don't think VMware is going anywhere today, but I definitely see the future dimming tomorrow.
I think what you'll
That's
see is
happening.
you'll see the VM engineers kind of migrate towards OpenStack as they see the writing on the wall.
Yeah, and
Once it's
it will
transition
take
period.
a long time. I'm not saying it's going to happen, you know, next year. 2019 is going to be the year that OpenStack overtakes VMware. That's probably pretty
Well,
naive to say.
it's interesting though for me, because I've been pursuing various certifications, and that was the next one on my list. But
Kubernetes.
But it's a big bite of personal investment to do it, and you know, maybe I don't want to do that if it's. If the
Well,
right
it puts
thing along.
VMware in quite a, I mean, they were on par, sort of a competitor with Red Hat, but now they're gonna need to pair up with somebody like another, like an Amazon or something to really. I mean, VMware did pair up with Amazon to create that the VMware on AWS. So they but it's not a full IBM purchase of Red Hat.
Right. Well, people got to still pay for the VMware, and they got to pay
Right,
for the
and
Amazon.
the
It's
VMware
like-
on AWS Cloud is so expensive. I don't see it ever. I don't know how that's gonna.
Their models are going to fall down. That stuff, virtualization was commoditized. Like, just as soon as they came out with it, it was commoditized. People just didn't trust it. And now it's in production. The world around, I mean, Amazon is moving to the KVM hypervisor, if that tells you anything about the stability of KVM. You best believe that they're betting couple billion dollar business on that technology being mature, stable, providing KVM, providing something, you know, some business advantage for their customers. Because at the end of the day, they got a business to run. They don't care how much money they pay for it or who they get it from. But if Amazon's willing to bet their public cloud business, which is massive, on the KVM hypervisor, why shouldn't everybody else? And that tells me that what that really tells me is that the value of virtualization is not much. And
I'd say it's scenario based. I mean, you think about like VDIs and like desktops and things of that nature. You're not really going to containerize that type of thing.
I mean, if you
You
go
might
look at
containerize the apps as appropriate, but if you're in a secure environment where you don't necessarily want persistence on the box, you're going to have a VDI on the wire for a while.
if you look at like Silverblue, which is a new Fedora release that is a fully containerized desktop. So our desktop apps coming, like pointy clicky apps on your desktop coming in containers, sure. It's coming, not there yet. I agree with you. It's many
Well, it's
years down
coming.
the road. Yeah, it's coming. It's years down the road. But I mean, it also takes years. I mean, if you think about any technology that you really know and understand deeply, like you could get up and have a talk about it and know everything there is to know about it. How long did it take you to learn that? Probably years plural. So if you're going to invest in a technology, invest your time, energy, and effort in a technology, invest in one that's going to be there 20 years from now. VMware is not. It's been there. It's already been there for 20 years, and it's getting life cycled. So I would learn, if I was you, I would learn OpenShift, which is just, Red Hat actually offers training on Kubernetes. I don't know if anybody else out there is offering somebody training and certification on Kubernetes, but it is important. And I think the whole pragmatic shift to OpenShift was really kind of driven at the college level. Like you were just talking about how, the college kids in the 90s were learning Microsoft because that's what was available. They didn't really have a whole
You
lot
saw
of
that. I
things.
mean, I went to college in the 90s, and I would tell you that the
Linux.
Microsoft model of funding made it cost prohibitive for a lot of us in the mid-90s to buy Microsoft products. So you saw a shift towards Linux at that point.
Mhm. Right.
You look at the development of Linux, you look at the roadmap of how quickly it developed versus Microsoft,
Mhm.
you know, over that next 8-year span, it was,
Crazy.
yeah. You know, the
Unprecedented.
availability of the product at that point, you know, it was easier to work with.
Right.
And even now, when you look at the cross-compiling and the other platforms, and you think about kids now with Raspberry Pis,
Mhm.
you know, any ARM processor or whatever it is that they have in their hand, I mean, it's all a derivative of, you know, the old 2 kernel moving forward, and that's kind of what things are moving towards as things kind of come full circle for us.
Right. Yeah. I absolutely agree with that. Couldn't have said it better myself. So I guess I'll move on to my presentation because I want to actually give you guys a chance to touch OpenStack. We're gonna just like move fast this blah blah blah. Community facts, yay. RDO. I got too many cookie buttons. So guest. So guest is something to talk about. OpenStack. If you use the KVM hypervisor, pretty much everything you guys are gonna have access to, everything you're gonna run, it's supported, including Windows. Demo. All right. So we can get on with this. So if you guys want to go ahead and connect to the demo network, you don't have to. It's this router sitting right here. You don't trust it, then you know, hey, you don't get to play. I don't care. That's your choice. Actually, I'm gonna turn this thing into yeah. You don't want to connect to random Wi-Fi networks.
I'm just thinking how, you know, we had early voting.
What's that?
We had early voting with everybody on.
It's not connected to anything. It's just it's right there on the desktop. There's no connection outbound.
That's how it starts.
Early voting, though, is a hacker's haven because you got all these people in line at the library on their phone while they're waiting for the line to get to the voting booth.
Okay. Yes, I want to keep my changes. So here's the Horizon dashboards. Yay, there is a GUI for OpenStack, although you should not use it unless you're showing other people how to use
Are we
OpenStack.
hooking up to 10.0?
Yeah, it's the 10 network. So if you want to jump on the demo Wi-Fi and go to 10.0.0.10, you should see the OpenStack dashboard. Turn on.
What's the
Not
password?
Mosaic Lab.
What's that?
What's the password?
The password, we'll get there in just a second. So
We're not hooking the Mosaic Lab then? We're hooking the
no, you use the demo Wi-Fi network. So there's a Wi-Fi network called Demo. It's open. Couldn't get much more secure, right? Like, I don't care. There's nothing on here.
Man, for
So-
a cyber guy, you demo without a password?
Yeah, that's right.
That's why it's a demo.
That's why it's a demo, and that's why it's only on one box, so you can't burn up anything expensive.
You
So-
see this big prompt
Is it
message
30? I can't read that. 30? You just do 30?
It's .10. So it's 10.0.0.10. So inside of OpenStack's dashboard, there are a whole bunch of folding panels that allow you to access these APIs. And it also, if you're an administrator, you can get some additional statuses.
This is Horizon we're looking at, or is
This is the
something?
Horizon dashboard. And if you're an administrator, you can get statuses on what's happening with your actual cloud. So whether or not the service is up and available, it gives you some basic reporting functions. It also tells you where your admin APIs, your public-facing APIs are at. So the Horizon dashboard is an example of an application coded to work with the OpenStack APIs. So if you were writing a web-based application or something of the like, and you wanted the app to just take care of itself, you could very easily, in say Python, write an app that monitors its own CPU utilization, and when it hits 80%, make an API call. That's not that complex to write or code. And the Horizon dashboard would show you exactly how that is done. So it's an example of example code on how to interact with the OpenStack dashboard. It also happens to be functional. So inside of my instances, this is the only part that is similar in OpenStack and VMware, is that you can spin up virtual machines. All the rest of it is.
And you're
is
saying
entirely
you can do this very same thing with heat commands.
Oh yeah, yeah. You could orchestrate all these things running in here, and I've got a Windows box. I've got a Linux box. They'll run side by side. They're connected to a virtualized network, and that virtual network, if you're familiar with VMware technology, it'd be like the same as NSX. If you had NSX set up and running, I've actually never seen somebody that actually had NSX working. I'm sure they're out there. I've just never seen them. So, OpenStack allows you to create virtual routers, which is what this is. It allows you to create external networks and private internal networks, and that's what we'll be working with today. Is a bunch of private internal networks. So, OpenStack's back-end technology by default is Open vSwitch. Has anybody in here ever heard of Open vSwitch or familiar with it at all? The Open vSwitch, for those who are not familiar with it, is a software-defined program that allows you to create virtualized networks, and you can select from a litany of different network styles. So you can use VLAN technology, you can use VXLAN technology, you can use, I always say this wrong, Geneva, I don't know how to say it. If you start Googling it, it will come up. And I want to say there's one more in there that's not really very popular. But you've got a couple of different layer 2 technologies that are available inside of Open vSwitch. In this particular use case, I'm using VXLAN technology to be able to create segmented private networks. And a segmented private network is one that only exists inside of the OpenStack cloud. So if you were to think of like an Amazon VPC, a private network that is not accessible or connected to the outside world. What happens in here, like the logical flow, is I sit out here, so this little world icon is a network that is physically externally connected. I connect my router to that network, and then each one of my instances I want to have publicly accessible. I would put what's called a floating IP address on this, and a floating IP address is quite simply source-based NAT. If you're familiar with source NAT, then you would know exactly how floating IPs work. So any inbound request. So I should probably maybe I'll bring my console up. So this wireless network is connected to port 0 on my little OpenStack box over there, and that is on the 10 network. So the external network in OpenStack is the 10 network, which is the same network that you're on. So you're logically on the same segment, right?
What's the net mask on your 10 network?
It's /24.
Okay.
So this guy
What are
here.
we logging in with?
What's that?
Are we logging in the ad username yet?
Not yet. You're excited to get logged in. Well, give me one more minute. I just want to explain how floating IPs work, because this is probably the most complicated part of actually interacting with OpenStack that people really don't seem to understand. If you're familiar with SourceNet, you'll know technically how it works. But essentially, I take a IP address here, this 10.0.0.68 network, and I NAT that. Anything destined for 10.0.0.68 would get natted back to, it's like one-to-one NAT, back to 168 or 192.168.100.17. So I can access that instance via a floating IP address.
So you can get to it from your world.
Yes, because I am on the 10 network, and I only know about the 10 network. That's the only network this box physically knows about.
Could you make the font bigger on your terminal?
Yeah, maybe I could.
A little bit, so
my
just
terminal,
help
yeah.
us read it a little bit.
Maybe.
Yeah, something, I think it's preferences or something is a way to do it. Yeah, perfect. Yeah.
So now I do a ping 10.0.0.68. I should get something back. Yay! I can reach OpenStack instance. Let's say that something wrong goes with this this test machine here. Try to zoom that in a little bit too, so people can actually see it. Okay. So let's say something wrong goes with this test instance here, or I just want to take that instance out of service. You can very easily do that using the floating IP method by just detaching that external access to this box.
It's still running, you just can't get to it
Yeah.
from outside.
It's still running. I just can't get to it. And as I said before, all this stuff should be driven with an API. But if I have an application or I have a service monitor or something like that looking for this floating IP address, maybe I want to move that to a different box and be able to easily point to the same service address. So if you thought of a floating IP as a service address for whatever application lies on that underlying virtual machine, I could take that floating IP and move it to any box and still have the same service address.
Is that similar to assigning an additional IP address to a NIC? Is that kind of what you're doing
It's
with that?
not doing that because it doesn't
Okay.
actually. So what's happening here is a combination of a couple of things.
You're doing the association somewhere within the OpenStack infrastructure then.
It happens at
Yeah.
the network layer, as opposed to just ad hoc adding this IP address to my instance. That would essentially take my instance and expose it to the
And you're
world.
doing it, so you're doing this separate from the instance. You're doing
Yes.
the layer above the instance is doing that IP mapping.
So we're gonna,
Yeah.
yes, that actually happens right here. So
Okay.
in the OpenStack router itself, that is where the NAT occurs. So this network here is the 10 network. This router right here is connected to the private network and the public network. So when something comes inbound for that 10.0.0.68 IP address, this router right here says, "Oh, I know where to send that traffic. I NAT that back to this IP
Isn't it
address." over
exactly
here."
the same as when you
route.
set up a little port map on a router?
It's different from port mapping because it's an entire IP address, but exact same technology. It's exactly the same technology. It's just natting a whole inbound IP as
So it covers
opposed to
all- any
natting a
port you
specific
throw at it.
port.
Yeah, you catch the whole thing. And
You
then
catch
when
the-
you have
All
its
the
own
whole port
IP
range
is-
goes.
So when I use that mechanism, I can kind of do some more interesting things with that IP address or with that break kind of in the chain that I can control. Because that IP address isn't attached to my instance, I can control what happens in between the edge network and the virtual machine. Because I've got a way to get in there. In OpenStack, that's called security group rules. And then the number two thing hearing problems with people have problems with OpenStack is they spin up an instance and then they go try to SSH into it or get into this box and it can't. They don't understand how.
Right.
That's because by default, the default is to drop all traffic. So I'm gonna go back over here. I'm gonna start my ping again. So in this security group rules section for this particular network or this particular project, I've got an allow all ICMP rule in here. So if I delete that rule, my pings are going to stop working. So this allows me to not worry about the firewall on every individual instance, and I can control things from a policy level. Web servers get this access. Database servers get this access. So I can control my firewall as policy as opposed to every individual instance having to have its own firewall. Because there's no way for an instance to be able to talk to another instance without me being explicit in saying so. It will allow all outbound traffic, and it will natively block all inbound traffic and natively allow all outbound traffic. But if I wanted to get granular, I could also tell that VM, I'm not going to let any of your traffic leave either. And I use a combination of Open vSwitch and IP tables to accomplish that because I can control the data flow and the data path to that virtual machine. That means that I can also control who has access when, how, where, and do all those things. So security group rules are mapped to virtualized instances. You can create as many of these security group rules as you want to. If I go back over here, see my pings right there. Super simple. So now everybody go ahead and log into the dashboard with the username operator and the password operator. So complex. So I'm going to show you guys this network topology screen in here, and it's a pretty simple topology. But let's say your use case for OpenStack is a little more complex. So when you guys get logged into the operator panel, go down to network and then click network topology and go to the graph screen that I'm on, and you'll see something a little more complex. So if you guys zoom out, you'll be able to see exactly how complex of a network I can create inside of OpenStack. And the only reason that there's not more there is because I'm only in this tiny little box, so I can only do so much. I'll bring it up on the screen so everybody that's streaming live.
Cloud, Heat.
I didn't do that with Heat. I did it with Bash, as a matter of fact. So you can use any mechanism you want to talk to OpenStack. I wrote a simple for loop, spins all that stuff
Really,
up.
because I mean, like creating it by manually, it takes like 15 minutes to create 3 instances because you gotta wait for it. How long does it take to create this once you run?
I started at 8 o'clock this morning.
And then it took like how many hours?
I was here. I live an hour and a half. I live an hour away, and I was here at 10.
You just let it run in your car?
No,
Oh, you mean it's?
it took 15 minutes.
Huh?
It took 15 minutes.
Oh, it did? Oh, really?
Yeah. OpenStack API requests are very simple to make. They don't take very long. It really, everything in OpenStack is database bound.
Oh.
So if your database is on like an NVMe card, then it responds back very quick.
Wow.
So that box has got an NVMe
All
card
of
in it.
this infrastructure in 15 minutes.
15 minutes.
That's
And it's all fully
I didn't
automated.
know. Okay, that's impressive.
So I can take this extremely complex infrastructure and spin this stuff up in a matter of a few minutes, and you guys can go ahead and launch instances against it attached to any of these networks. If you want to add your SSH keys to it, you can SSH into the boxes. There's Windows instances in here. So, I mean, really this example is just to show you exactly how complex you can get. And if I zoom in on each one of these gray boxes, or each one of these boxes with a little cloudy thing in it, if you were to think of this as infrastructure, real infrastructure, that's a real switch.
What do
Every
the
router
colors mean?
is a reroute. They don't mean anything. It's just so you don't get confused when you look at the world view.
Okay.
Yeah, the colors don't really mean anything. It's just so you can set.
How come you don't have a line going with a gateway going out to the NDOT network?
Because I didn't put it in there. Do you want to do that?
Yeah.
So
Well, I mean, I
there's-
thought that would have been required in order to get us to connect into it.
So we're not now. We're in, and this is another concept I haven't really covered at all. Is OpenStack is also multi-tenant. So when I was just logged in the other project, I was logged into the administrative project. This is the operator project. So multi-tenancy is this mechanism which I use Linux namespaces and Linux control groups to logically separate resources. So I can create the same network over and over and over and over again. So I could create the 192.168.1.0/24 network in every single tenant, and those IP addresses would never conflict because they use the same technology as if you go all the way back to the old school Cisco days where you could create virtual routers, VRFs inside of a Cisco router or a VLAN. I mean, those are quite literally separate instances of the kernel running. OpenStack does the same thing at scale. And it works extremely well. I mean, it was proven to work in router and switch technology. Why would we have any reason to believe it wouldn't work very well in Linux? What's that?
Still in use.
Still in use. Works great. Why get rid of it? So OpenStack is also multi-tenant. So this network doesn't. I don't know if this has a connection into to the external network. But if you go and look in the Networks tab, it will tell you very quickly. There are 90 networks here.
Well, how many virtual machines do you have and how much disk space? Because
Virtual
that's
machine?
been the problem I had when I'm installing OpenStack is the machine and the disk space. I had a laptop, I had 50 gig, I had like 16 gigabytes and I was maxed out with 3 instances.
You might be
How are
using
you doing
QCal2
Huh?
images, QCal2 formatted images where they don't take up all the
It's just the deltas.
the space.
Well,
that-
even the tiny cows, whatever they're called, tiny instances. What's the size
So-
of the instances you're doing on this, and what?
Oh, those are virtual switches and virtual routers.
There's
They
no
cost
instances.
nothing.
Okay.
They're
there's no
free.
instances.
They cost nothing. They're not virtual instances. So that's the difference in between OpenStack and VMware. Is to do this in VMware, I would have to create a virtual instance for every single one of those functions that I was trying to virtualize, as opposed to letting the infrastructure take care of it for me. So it's baked into the host operating system.
Just separate PIDs in the same system.
So you can see here CPU utilization. This is pretty much at idle system, but OpenStack, and this is just a tiny little Xenon D, cheapest Xenon D you can buy. It's not the most expensive. It's the cheapest. That box has got 32 gigs of RAM and an NVMe card in it, and overall CPU utilization with OpenStack, and I want to say a couple of instances. I see a couple of KEYLUG KVM. I think there's 2 Linux boxes and a Windows box running right now. And overall usage is somewhere around 10 to 15% of what the box is capable of doing. So it's got a lot more left to give. Disk space.
How much does SE Linux come into play within the OpenStack?
So I'm really glad you asked that. So we'll do PS KVM. Oh God.
Like WC-L.
What are you trying to
Yeah.
find?
I'm not trying to count the numbers. I'm trying to get the SE Linux context. I just want to cut all this crap off.
Can
Yeah,
you show
whatever.
us the for loop you did to kind of create this infrastructure?
Sure. So if we look here in capital Z, so this guy is running in.
Would you, maybe you could do
Unconfined.
carriage returns so you could put that one line higher up so people can see it? if that would
Yeah,
help you.
I'm gonna fix
I don't think
that.
you guys can see it very well from back there.
I'm trying to figure out where it's.
Sure. Once you get your command debug, then we can do it. Okay.
There you go.
Ah, awesome, okay. Yeah, can you put that up to the top and then, no, just hit a bunch of carriage returns and
Oh,
then
okay.
run the command again. Gotcha, yeah, now run it again so they can see it at the top. Well, that's not gonna work, is it? Yeah.
Right. No, it's not good.
Oh, okay.
So I see my 3 instances here, and then there's this technology called SVirt. And if you'll notice, all of these, so what I'm doing right now is I'm displaying the SE Linux context that these sit into. So all of them are in their own domain. That means that even somebody was to break into the guest kernel and into the host operating system, they can't go anywhere and do anything because nothing else is labeled with this instance label or that domain label. So you can't even do anything in the host operating system, even if you did break into it.
Those
You
are the
wouldn't be able to do anything.
C777 Queen U, C380 Queen U.
These guys right here. So
Yeah.
these are all my virtual instances.
Right.
That's why it says SVirt. And each one is placed in its own context. So SE Linux is a fairly secure technology. I don't know that there's a lot out there that's any better as far as mandatory access control systems go. And by default, OpenStack will put each individual instance into its own domain. So all of these guys are not only segmented by namespaces and C groups, so that's how quality of the service is done.
There's your multi-tenancy with that capability.
That's your multi-tenancy
Yeah.
right there.
Yeah.
That's how it works. Any questions about any of that? That was a really great question, by the way. I was going to totally forget about SE Linux. So we'll go look at my image store, and you guys feel free to click around. Like, you can spin up or touch anything you want to. There's nothing in here that can break. I just built this box. I built this box at like 9 o'clock last night, got it loaded with images, and I spun up all the networks this morning. It takes less than an hour to get OpenStack up and running. It's really simple. Like, you've got to try really hard to screw it up. And I loaded all these instances in there last night. So CentOS, Ceros, Debian, Fedora, OpenSUSE, RHEL, Ubuntu, Windows are all instances that you can feel free to launch.
Now, these are stored in the Glance storage.
Yes. So
So-
Glance is the project for image storage, and all these file systems are preloaded. I can also associate metadata tags in here. So if I wanted to say something about this instance, like let's say I want to say this instance here has a config drive, or maybe I'm going to change the SCSI bus that it uses. So instead of using VirtIO block, I'll use VirtIO SCSI. If I want to change anything about the image and saying, hey, before you fire this image up, these are my requirements, I could put that in the metadata. I could also put useful information in there like build date, build ID, so that way I can track this image all the way through my infrastructure.
If a developer were,
Oh, no, go ahead.
yeah, if a developer were working on coding a particular image to change it, add some functionality or something, and they had a Git process where, and could you push or redeploy the updates to that image, from
So images
developer?
are immutable. Images are what they are.
So you have to bring it down and
So
start
you
it
would
again.
either, you could rename it to the date that's like build date or something like that, and
So
you
they're
can have
cattle, basically.
their cattle, right?
Okay,
We're gonna
that's the answer,
if I got an old image, I'm gonna shoot it in the head and I'm gonna get a new one.
So if you're going to go to a 1.2 to a 1.3, then you're going to kill the 1.2 and relaunch it as a 1.3. Is the answer to that?
Right.
That
So,
answered me. Yeah.
I see your images, the
Mhm.
Cirrus
Oh, it's
image
not letting
is
me
part
do it
of the
'cause I'm not-
standard library that comes with OpenStack, but then you've got OpenSUSE and you've got
Mhm.
Ubuntu 18.04 and the Windows 2012. I would thought you'd have to go get each ISO, move it to a disk, and then load it, and then put image and open, and then run that little. How did you do this quickly?
All these people produce these images. They're already ready for download. You just download them.
Even the Windows image?
Hmm?
Yep.
Oh,
What from what repository?
yeah. You would download that from Cloudbase.
Cloud-based.
Hmm. Yeah, they make an OpenStack image for Windows.
Cloud-based.
Yeah, they're the ones that write CloudInit for Windows, so you can control Windows in a cloudy fashion.
Well, how does that work for licensing?
So as far as Microsoft is concerned at this point, I believe that you can fire off any Windows instance for free for 30 days.
Okay.
Once it lapses the 30-day window, you do need to pay for it. But they, like Red Hat, I think the operating system market is so commoditized at this point. Like, why pay for an OS? I mean, that's why Linux. That's not the reason why. You had the reason why earlier. It was the developers and people who learned it earlier in the 90s. But really, why should somebody pay for an OS at this point? It should just be free. Like, it's been commoditized.
So go to cloud-based, and I don't have to.
I
go
can't, I
to
don't have internet.
Ubuntu- No, I'm just saying.
Yeah.
You go to cloud-based, I don't have to go to the Ubuntu download site and get the image and do all
So
that.
if you want Ubuntu, you go to Ubuntu, and the OpenStack page tells you, like if you type in OpenStack images into Google, it will take you to the OpenStack page, which points you to all the place where all the images are at. And it took, like I said, I downloaded all these images last night, and on the actual file system itself. So if I look in images, no, that's not where I'm looking. I'm looking in the wrong place. 14 gigs. So all of those images occupy 14 gigs on my file system. And if I look at the instances that are running right now, 13 gigs is what they actually use.
And that's how many images?
These that's
a lot.
That's these images here. I mean, that's pretty much every operating system available. And if I was running this in in my house, I have 2 operating systems I work with: Fedora and Red Hat. That's it. I have 2 images that I maintain because I use Fedora on all my desktops because I like it. And I use Red Hat for all my development stuff and all my servers because I work at Red Hat. So it's easy.
Calculus is easy.
But if you guys wanted to use Red Hat at home, you can get it for free. You guys know that? I don't know if anybody knows that.
RHEL?
RHEL, yeah, you can get
RHEL.
RHEL for free.
Yeah.
You don't have to pay for it with RHEL. Good developers.
It's good news. GPL open source.
Well, is it the CentOS
No,
realm?
no.
No.
CentOS is not RHEL. CentOS is not RHEL.
It's its own beast.
So
It
you
is
go
its
to
own
develop-
beast. Like CentOS does crazy things. Like when FIPS didn't work right, they just skipped it in the kernel and then built it anyways. You could turn FIPS on, but it didn't do anything.
Well,
This
then what
was
kind, I mean, RHEL 7.5, or you can get it from the
free
developer
for
website.
free for free.
Well, it's just then licensed as a developer.
There's no license. Red Hat's not a license. There's no license.
It's
The license
licensed
is-
to GPL.
Yeah,
There's
that's
a,
right.
there's an enterprise RHEL licensing.
That's for your service support.
That's a subscription. That's
Subscription. It's different. It's not a
What-
license.
That you get support. you
the
mean?
support
You don't
subscription
get
is what it is.
You can get support from the developer. You can get a subscription for free
Okay.
with RHEL. Yeah.
Oh.
Developers.redhat.com. Just in case you didn't know. Microsoft, everybody does it. I mean, if you're not offering a free version of your operating system at this point, you're pretty far behind.
Wait,
You're not gonna
maybe
make
I'm
it.
behind. I didn't even know Windows has got free licenses now.
Yeah, you can't run it permanently.
You have, well, I mean,
Image
like,
for
I
90
mean, you have
days.
free
Yeah.
trials, but not like.
No, I think Microsoft has even moved past the free trial thing. It's like they know what people's development cycle looks like.
It's like a 90 to 90. So like you do it 90 days and then you reactivate for another 90.
I'm not a Win. I have
Oh, I
no
know there
Windows
was
in my
a
house at all.
190 or
180
180 thing or
Yeah.
something, but I didn't.
It's not a-
activated.
Yeah, it's not a thing. Really. I mean, they're pretty aware of the fact that dev
I know.
cycles are not short.
Oh.
So
now,
the
if
other,
you're using it in production, probably a little bit different story. Maybe
Yeah.
specificity about that.
they might get a little salty.
Yeah, I mean, they still take a lot of money from us for what they call software assurance, so every desktop that's in use, we true up every year, you know, whatever we get, $100 a desktop.
Yeah, I know for enterprise use, but I didn't know how easy it was for just getting images to load on your own developer home network thing.
Yeah, go to Microsoft.com or Red Hat or wherever you're going to go to get
I
whatever
didn't
image you
want
need.
the pain in the butt of getting the expiration, 100 days from now. And,
Well,
it's
so
from
that's the
100 days
interesting thing about
install.
OpenStack is you just put that image in the repository, and then every 90 days you just fire off a new one. It's not the same. It's a new image. It's a new box. And if you automate those processes, like I said, you don't point and click your way to success here. You automate things. Use something like Ansible to automate an action occurring. So maybe you were to automate something like, hey, I want to permanently have Active Directory for like ever and ever. So maybe I'll just automate the whole process of standing up an Active Directory server with OpenStack and Ansible, and then run a cron job every 90 days to tear down the old one and stand up the new one. and
Well,
just have them
if
run
this
the
not part of this discussion topic, but Ansible, would you be running an image with Ansible in OpenStack?
No, Ansible is an automation technology. So Ansible, I need the internet right now.
I know this is not an Ansible presentation.
Yeah, that's fine. I cover Ansible. I cover everything, so it doesn't bother me at all. I'm just gonna jump on the internet, and I'll show you what Ansible code looks like to interact with OpenStack, and how I mean, it's pretty complex to like get up and running. You guys will see here in a minute. I'll show you how hard it is. It's okay, I'm not waiting on you. So here is some.
Engineer for beer?
Here is some so this is what it takes to spin up an OpenStack instance in Ansible.
That's
A
an
whole-
Ansible playbook, yeah.
A whole 15 lines of code.
Oh, wow.
And this is all variabilized, so you can put this in a for loop and just run it and run it and run it
I
and
need to
run
start
it.
using some automation then.
Yeah, it's so easy. If I want to do something complex, like this is something I wrote because I was bored and I wanted to see what a CI pipeline looks like in Ansible. So what this thing does is it enables the repository. So I would point this at an OpenStack instance once it's up and running. I point this playbook at that, and it installs some packages. It checks to make sure bro is installed, which is the binary that I built. The image that I built was for bro, which is a network security tool. I conducted an OpenStack scan of that. I turn around and create a Swift container, so an object store container to store the data in from my scan. And then I upload the unit test, the SCAP report. In the SCAP report, I use both the HTML version and then the stick viewer version. And then I turn around and harden that system, and then I run post-hardening, and then I upload the output of that to the object store. So it's all relatively simple automation. None of this is super complex. I mean, I have a whole, like, I can build and check an image in about 55 lines of code.
Cool.
You don't know about Ansible. You don't even have to learn it because it's not hard. It is stupid simple. Like, you have to try to figure it out. To go way out of your way. It's a little bit of a learning curve. About 10 seconds. And
What stig are you using there when
This?
you did that?
using the DisStig
How are you automating a DisStig?
because it ships in RHEL by default.
The stig and the...
Yeah, we did that like 5 years ago.
You can do that with a lot of vendors now. They'll pre-stig for you. You can just order.
Oh, you mean, you got a pre-stig image.
I'm building them. That's what I'm building here is a pre-hardened, pre-baked, fully DisStig image. But even if I install it from ISO, I can do that on Fedora. I can do that on RHEL.
Well, I mean, I've been doing it manually.
On
How do
production
you
boxes.
do...
Why? Oh my God! I gotta take you to a website. Yeah, I'm gonna show you some. Oh my God! You are killing yourself right now.
Yes, I'm
Scap
killing
Workbench
myself.
right here. You need this tool right here. I'm gonna make this real easy for you. I haven't installed it because I usually use the command line. Yeah, the Workbench. Oh my God, man! You are trying to kill yourself.
We have a bunch of us that all do.
Hours on the contract, I guess.
It does. So I've got my SCAP guide. It's called.
Figure out why we haven't been using this.
So OpenSCAP is a NIST validated scanner. DISA requires that you use a NIST validated scanner. They don't say you have to use
I can
ACAS.
see that rule, yeah.
You don't have to use ACAS. They recommend that you use ACAS, but you don't have to. You
Oh, really?
have to use a NIST validated scanner. That is required.
That's a lifesaver for me because I do SCADA assessments.
Mhm.
There are a lot of Linux machines in the environment where they don't want to run active scanners on them. So I pick up this machine and install OpenStack on that
Oh.
and run the scan and get a baseline out of it.
So
you're
I'm
saying
gonna run a scan on my box.
OpenStack
I'm gonna run a scan.
will implement the stig?
Yep.
Oh.
It'll get you about an 80% right
And 80% of the stig, the Cat 1 and Cat 2s?
now. I just ran a scan on my box right here.
Oh.
So I'm running a scan from, and this is a Fedora stig that's using the operating system protection profile general purpose systems. But you can load a DisStig in here. In the SCAP Workbench, I can also point this at a remote system and scan a remote system.
Oh, wow.
That's if you have to use a GUI driven tool. If you're fine with the command line, there's command line stuff. If you want to see how the command line done, it's an Engineer for Beer. Quite literally how to do the DisStig and output a report. And it will output both the HTML report and the Stig Viewer report at the same time. Yeah, it's right there.
God, you saved me like tons of work.